Hey everyone, this is lesson or day 4 of Unit 1, and the topic is contestants, can you solve this limit? The idea of this lesson is to be able to evaluate limits with algebra. So we're going to start looking at symbolic approaches to finding limits. And you were supposed to work through the contestants, can you solve this limit, problems 1 through 8 on your own. So I've got some solutions for you to check your work. Question 1 asks us to evaluate limits using direct substitution if possible. So what does direct substitution mean? If we have a nice function, then our limit is sometimes just the value of our function. So we can try that. Plug in a 2 everywhere you see the x. You get 2 squared plus 2 take away 6, which is 4 plus 2, so 6 minus 6, which is 0. And in the denominator, we get 2 squared, which is 4, and 4 minus 4 is 0. So we get 0 divided by 0, which is undefined, so we cannot evaluate our limit that way. 0 over 0 is what's called an indeterminate form. So I don't really want to say that the limit doesn't exist yet. I just can't do anything when I see 0 over 0. So why did that happen? Well, let's take a look at Desmos. So if I graph f of x equals x squared plus x minus 6 over x squared plus 4, I see a vertical asymptote here at negative 2, but at positive 2, let's see if I can land right on it. Did you see it? It was there, right there. We are undefined there. The graph has a hole in it. Desmos will actually show the hole if you put your finger or your cursor right on top of it. But we are undefined at x equals 2 because both the numerator and denominator are 0. So we don't have an asymptote because it's not like a number divided by 0. We get a hole when we have 0 divided by 0. So if we do look at the graph and look close to x equals 2, it does appear that we have a limit, and it looks like it's bigger than 1 but smaller than 2. It's not halfway, so I thought that it looked like 1.25, although trying to tell from this graph is certainly not an easy thing to do. We could make a table and I'm going to change this to f of x1, and we could type in values extremely close to 2 like 1.9 or 1.99, 1.999. It looks like we're getting close to 1.25. We might try something like 2.001 so we can see the limit from the right and from the left. And it seems rather convincing that 1.25 is our limit, but that's hardly a proof. And that's what we're going to want to do with algebra. So question 3 asks you to factor the numerator and denominator and see if you can simplify it at all. And it turns out that negative 2 times 3 is negative 6, and negative 2 plus 3 is 1. So we can actually factor the numerator as x minus 2 times x plus 3. And the denominator is the difference of two squares. It factors as x minus 2 times x plus 2. And we can cancel the x minus 2 in the numerator and denominator as long as we're not talking about x equals 2. And you might be asking, well, wait a minute, isn't that exactly what we tried to plug in here? Well, yeah, and when we did, it was undefined, but when we find a limit, we're only concerned with what's happening really, really close to 2. We're looking at 2-ish instead of exactly 2. So we can go ahead and cancel out the x minus 2's, leaving us with x plus 3 times x plus 2. And now if we retry our direct substitution and plug in 2 for the x, we get 5 over 4, which as a decimal is 1.25. The same value that we saw in both the graph and the table. So question number 4 says find the limit using the graph. Y is evaluating the limit at x equals -2 different than evaluating at 2. Well, we're looking at the same function, but now we're looking at -2, where we definitely have this vertical asymptote. So we're going to say the limit does not exist. And when we try using substitution, we get -4 over 0. And this I can say does not exist. Does not exist. Because -4 divided by 0 is very, very different from 0 divided by 0. -4 divided by something that's getting really, really small is going to be like multiplying by a reciprocal, which is getting really, really big. -4 over 0 is going to go to infinity or negative infinity, depending on whether we're at the positive side of 0 or the negative side of 0. So 4 over 0 is going to be either infinity or negative infinity. But I can't tell what 0 over 0 does. Depends on, how close to the actual 0 the almost 0 is, if that makes sense. Question number 5 says use direct substitution if possible. We run into trouble again because if you find the tangent of 0, it's 0, and if you plug 0 in for x, it's 0, so you get 0 over 0 again. But if we rewrite it using sines and cosines, we can turn tangent into sine over cosine. And now I've got this 3-level fraction, so I might consider doing some algebra here. To fill in the gap, I changed my division into multiplying by the reciprocal, which then turned into sine x over x cosine x, which doesn't look that much better, right? Question 7 is right. If you write it as a product of two fractions, though, I can separate out the sine x over x. And we actually did this one in a prior lesson. Sine x over x is a famous limit, and I want you to be aware of this one. We're going to want to write this one down. The limit as x approaches 0 of sine x divided by x is equal to 1. So if we follow procedure here, which with this multiplication turn it into two separate limits. The first limit is 1. The second limit we can do with direct substitution because cosine of 0 is 1. We get 1 times 1 over 1, which is 1. All right, now I'm going to put some notes up here. I recommend that you pause the video at this point and copy these into your notes. On the left in blue, I've got some strategies for you to attempt to evaluate some limits. As you do the check your understanding questions below, you might want to refer back to these strategies. When evaluating limits, the first thing you're going to want to try is direct substitution. But to be honest, in this course, that's often going to fail, but it is the easiest way when it doesn't fail. So it should always be tried first. Plug in whatever x is into the equation and see if you don't get 0 over 0. Because if you get something other than 0 over 0, you can actually answer the question. There's certain limits that you should be familiar with. These two are particularly important if you go on to take the IB course next year, if you are only a junior this year. But otherwise, I don't know, you'll have another strategy that'll allow you to do these easily without memorizing them, but it won't happen until try 2 or try 3 of the course. So for now, I want you to know that the limit as x approaches 0 of sine x over x is 1, and the limit as x approaches 0 of 1 minus cosine x over x is 0. If it's not one of these forms, you can try some algebra like factoring and canceling and using direct substitution, just like we did on the previous page. There's other algebra that you can try, things like finding common denominators if you have two fractions, or rationalizing if you have a square root. And when all else fails, we can always resort back to making a graph or a table. Now, when it comes to algebraic limits, there are some properties that you should be familiar with. If we have a horizontal line like y equals 2, then every limit will be 2. Doesn't matter where the x value is. If you have the limit of a constant times a function, then we can do a constant times the limit of the function. If you're adding or subtracting or multiplying two functions together, you can add, subtract, or multiply the limits. You can also divide them, but dividing comes with a catch. You're not allowed to divide by 0, so the property only works if you're not dividing by 0. There's some other things that I want you to jot down dealing with fractions involving 0 and infinity. If you have a number divided by 0 that is going to approach infinity, like on the previous page when we saw 4 divided by 0, that's going to go off to infinity or negative infinity depending on the sign of k and what side of 0 you're on. Remember, a positive divided by a positive will be positive, and if you have one positive and one negative, it'll be negative. 0 divided by k is going to be 0, right? Even if this is 0-ish. If k is not 0, 0 divided by anything is going to approach 0. If you have a number divided by infinity, which we can't really divide by infinity, so what this means is a number divided by something that is growing extremely large, then your output will be extremely small, 0. But if you have 0 over 0 or infinity over infinity, those are called indeterminate, and you can't tell what the answer is going to be without doing extra work. So I would encourage you to try these check your understanding questions on your own. So go ahead, pause the video, give them a try. All right, let's try them here. I can try direct substitution, but when I plug in -2, I'm going to get 0 on the bottom. And 4 plus 8 is 12, minus 12 is 0 as well. So this approaches 0 over 0, so we need to try some algebra. I'm going to try factoring. I'm noticing that the numerator factors as x plus 2 times x minus 6. And that's going to allow me to cancel the x plus 2's. And now I can use direct substitution to evaluate my limit and get -8. Question 2, if I try plugging in 4, I'm going to get 4 minus 4, which is 0 on the top, and 2 minus 2 on the bottom. And this one's not really factorable because of the square root, but we can use another trick. I am going to multiply by something called the conjugate. And it looks like this: 2 plus root x over 2 plus root x. So really I'm multiplying by 1 because the top and bottom are the same. But now if I FOIL out that numerator, we're going to get the limit as x approaches 4 of, let's FOIL it out. 4 times 2 is 8, plus 4 root x minus 2x minus x root x. And in the denominator, when you FOIL it out, you're going to get 4 plus 2 root x minus 2 root x, and then root x times root x is x. So we're going to get some cancellation in the denominator, where those 2 root x's go away. And now if we do a little bit more simplifying, let's see. You know what? I'm seeing something that is causing me regrets. Right now I see 4 take away x, and in the numerator I see 4 take away x. What if I never multiplied that out? What if I left it, instead of FOILing, what if I left 4 minus x times 2 plus root x? Now after my 2 root x and my -2 root x cancel, this becomes the limit as x approaches 4 of 4 minus x times 2 plus root x over 4 minus x. And I maybe wouldn't have seen it if I would have actually FOILed out the numerator, but now I do have cancellation. And I can, at this point, use direct substitution because I've canceled the part that caused a 0 in my denominator. So now I can do 2 plus root 4, which is 2 plus 2, which is 4. And I have evaluated an otherwise difficult limit. Number 3, what I'm seeing here is sine x over x. So I'm going to split this up as the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of 1 over 2x minus 1. And the limit on the left is one of the forms that we should know. This limit is 1, and the second limit can be done with direct substitution, giving us 1 times negative 1, which is negative 1. Question 4 is looking at some properties of limits. They are surprisingly simple. This should be the limit as x approaches 2 of g plus the limit as x approaches 2 of h, and those are both sitting right up here. This becomes 0 plus 5, which is 5. And h is 5. This is going to be 3 times 5, which is 15. So the properties are nice and simple, and if you think about them, they make sense. If you try the product, you can do that just as easily. G is approaching 0, and h is approaching 5, and 0 times 5 is 0. But in part D, you're going to, and I'm going to use the property, this is the limit as x approaches 2 of h of x over the limit as x approaches 2 of g of x, which is 5 divided by 0. Now, I am not going to put an equal sign here because you can't be equal to 5 over 0 because that's undefined. So this does not exist. All right, problem 5, we have a piecewise defined function, which looks like it might be difficult, but remember what these symbols mean. This means from the left. And if I'm to the left of 1, it means I'm less than 1, so I can find my limit using 12 minus 2x, which I can do with direct substitution. This is going to be 12 minus 2 times 1, which is 12 minus 2, which is 10. And the limit from the right, remember that plus sign means from the right. Well, if I'm coming from the right of 1, it means I'm bigger than 1, which is putting me in this spot in the domain. So I'm going to plug 1 in to this equation. 1 squared minus 3 over 5, which is negative 2 over 5. And now the last one is asking if the limit exists. Well, the limit will exist if the limit from the left and the limit from the right are the same, and 10 and negative 2/5 are not, so this does not exist because the limit as x approaches 1 from the left is not the same as the limit as x approaches 1 from the right. And that completes our lesson.